So this unit is going to be a very quick introduction into acids and bases. So the very most basic definition of an acid and a base is the Arrhenius acid and Arrhenius base definition. And so this is something that you should be familiar with because when we were looking at writing chemical reactions, I talked about the fact that acids start with a hydrogen while bases have a metal followed by hydroxide. So for an Arrhenius acid, it is going to be producing a hydrogen ion. So if you look at HCl, for example, that is an acid. It starts with H. When it breaks apart, if I dissolve it in water, it's going to break apart into hydrogen ions, H+, and Cl-. Okay? It could also work for something like nitric acid, HNO3. It would break apart into H+ and NO3-. And so recognizing an acid as something that starts with hydrogen, that is something we're familiar with, and that's the Arrhenius acid definition, that it would produce a hydrogen ion, and so they tend to start with hydrogen. For Arrhenius bases, it is going to be a compound that ends in OH, and when it ionizes or when it breaks apart into ions, it's going to form hydroxide and then the metal ion. So here you see sodium hydroxide, NaOH. It's going to form Na+ and OH-. And so again, this is something we're familiar with because we noted that if you have a compound that has a metal and hydroxide, it's going to be a base. Now let's talk about naming acids because you already know how to name bases because remember a base, as we just said, is a metal followed by hydroxide. So you know how to name those because that is a typical ionic compound that we've looked at. When we're naming acids, however, they're going to have unique and new names. So let's go over that. So if you have just an anion, so for example, HCl or HI or HBr, your acid is going to start with hydro and it's going to end in ic. So for example, if you have HCl, that's hydrochloric acid. If you have HBr, it's going to be hydrobromic acid. If you have HI, it's going to be hydroiodic acid. Okay, so that's only if you have an anion. Now, if your acid has a polyatomic anion, okay, if that polyatomic anion has the ending of ITE, that ITE becomes us, while if it has an ATE ending, it becomes ic, and you don't have hydro. Okay, so really easy way to remember this. My student said this years ago. If it is just us, then it is all right, or ite. And then if it is more than 8 people, 8, it is ic. So 8 is ic, and us is ite. So if that helps you memorize it, awesome. So for example, if you have HNO3, NO3 is nitrate, so that would be nitric acid because the 8 became an ic. If instead you had HNO2, NO2 is nitrite, so that would be nitrous acid. And notice we're not adding hydro to it. And so the very last thing for all of these is that you just add an acid at the end. Okay? So just as a review, if you just have your hydrogen followed by an anion, you're going to have hydro and ic for the ending. If you have a polyatomic anion, if it has an ITE ending, it will become us. And if you have an ATE ending, it will become ic. So let's look at some examples. So if you have HCl, it's going to be hydrochloric acid. Okay? Well, let's look at, for example, if I give you the name and you need to actually write out the formula. So if I have phosphoric acid, okay, that looks like possibly phosphorus or phosphate. And the way that I know that it comes from phosphate is because I don't have hydro in front. So I have phosphoric acid, which is coming from phosphate. Remember, phosphate has a 3- charge, while hydrogen has a +1 charge. So when I'm creating my acids, I need to again cross my charges. So hydrogen's +1, PO4 is a 3- charge, so the formula for this would be H3PO4. Okay? If I did another one, I'll just pull one up out of thin air. What if I did sulfurous acid? Okay? So if I have sulfurous acid, that tells me that comes from sulfite, whose formula is SO3. The charge of SO3 is 2-, so when I cross H+ with SO3 2-, that gives me the formula of H2SO3. So that is the formula for sulfurous acid. And that's all you need to do. So you just need to remember these rules, and then you won't have trouble naming your acids at all. The very last thing I'm going to go over is a new definition for acids and bases, and that's the Brønsted-Lowry acid-base definition. So a Brønsted-Lowry acid donates a hydrogen ion, while a Brønsted-Lowry base accepts a hydrogen ion. So that's a good way to remember that. It's the bad rule. Bases accept while acids donate hydrogen ions. So now we don't have the obvious acid producing H+ with a base producing OH- that we had with the Arrhenius definition. Instead, we're going to be talking about hydrogen ion gaining and hydrogen ion loss. Okay, so if you look at this example right here, you have NH3 reacting with water, ammonia reacting with water, and it produces ammonium and hydroxide. Ammonia is going to act as the base because if you look, ammonia goes from NH3 to NH4+, which occurs because it accepts a hydrogen ion. One key thing to note, since it is gaining a hydrogen ion, it becomes NH4+ because the hydrogen has a +1 charge. So while ammonia is the base, ammonium is going to be what we call our conjugate acid. Okay, so every base has a conjugate acid, every acid has a conjugate base. So ammonia is the base because it is accepting a hydrogen ion, becoming NH4+. Water is the acid. Notice water, because it loses a hydrogen, it had no charge to begin with, then it becomes OH- because it lost that plus from the hydrogen ion. Therefore, while water is your acid, hydroxide is going to be your conjugate base. So let's look at some more examples of conjugate acid-base pairs. Okay, so HF, if HF is an acid, then F- would be its conjugate base because HF lost its hydrogen ion and therefore it's going to have a negative charge, so it's going to become F-. Now if water instead is acting as a base, it's going to accept a hydrogen, so it would become, instead of H2O, it's going to become H3O because it gained a hydrogen, and it will have a plus charge because it gained that hydrogen ion. All right? Let's look at another example. I have HCl plus OH- produces H2O plus Cl-. So I know the hydrochloric acid, HCl, and the chloride ion on the product side are going to be paired together. HCl to Cl-, HCl lost a hydrogen ion, therefore it is going to be an acid, while Cl- is its conjugate base. Hydroxide gained a hydrogen ion, so it's going to be the base, to become H2O. Notice H2O doesn't have a charge because the OH-, that minus charge was canceled out with the plus charge of H+, and so water is going to be its conjugate acid. And that's it.